Welcome to Grades of Green's Adult Learning Series, your free resource to learn about climate change and bring climate action to your community. I'm your host, Jack Magner.
While climate change and the climate crisis seem to be growing more and more apparent in our daily lives, at the same time, for those who want to learn more about climate change, it can feel almost impossible to know where to start. To address this need, we've designed this module to provide an introduction to the science behind climate change, so that you can feel more prepared to carry out lessons and lead discussions around climate topics in your classroom and in your school community. By the end of this module, you will be able to distinguish between weather and climate, compare and contrast past instances of climate change with modern-day climate change, explain what greenhouse gases are and how they impact global temperatures, and provide examples of how increasing global temperatures impact additional climate factors. Let's get started. Part 1. What goes into the climate? To understand how the climate is changing, we first have to understand what climate really is in the first place. One helpful way to better understand climate is to compare and contrast it to weather. When you hear about weather on the news, your local meteorologist is talking about short-term atmospheric conditions for a specific time at a particular place. This may include temperature, humidity, precipitation, wind speed, and atmospheric pressure measurements, just to name a few. Put simply, weather describes what is happening in the local atmosphere on a daily or weekly basis. On the other hand, the climate represents long-term patterns and averages of weather conditions in a particular region over an extended period of time, usually decades or centuries. It includes the same weather measurements mentioned earlier, just on a much longer timescale. Data on each day's temperature, humidity, and precipitation, for example, are averaged out to capture an overall picture of that region's unique climate. We can also think of climate on a global level, averaging temperature, precipitation, and other atmospheric measurements from all over the world. While the weather changes throughout the day or week, an area's climate is far more stable, showing how atmospheric conditions tend to look over many, many years. Now, to better understand climate change, let's take a closer look at the key environmental factors that shape our climate today. Take a look at this map of Earth's climatic zones. You may notice a pattern in how the climate changes as we move away from the equator. Let's dive a bit deeper into the specifics, starting with latitude. A region's latitude, how far north or south it is from the equator, plays one of the most important roles in determining a region's climatic conditions. Areas that are closer to Earth's poles receive less direct sunlight and solar radiation, leading to lower average temperatures. The opposite is true for regions closer to the equator that receive the most direct sunlight and solar radiation. This also has a direct impact on pressure and rainfall of an area. Warm air at the equator tends to rise and cool once it reaches a high enough altitude, creating stable, consistent patterns of rain that over time have created tropical climates. When this air reaches the stratosphere, air pressure causes the air to spread out, progressively losing moisture and sinking as dry air. This is why we see bands of rainforest and desert climates as you move away from the equator. You might be wondering why the air doesn't keep rising all the way up to the poles, eventually falling back down to the equator in one singular cell. Earth's rotation, along with the uneven distribution of land around the globe, leads to 3 distinct cells that carry the world's wind patterns. Water also plays a major role in shaping a region's climate. Because water holds onto heat efficiently, regions that are closer to large bodies of water tend to have more moderate average temperatures than areas further inland. For example, Los Angeles, California, Phoenix, Arizona, and Atlanta, Georgia all lie on similar latitudes, but LA's proximity to the Pacific Ocean leads to much more stable yearly temperatures. These are just a few factors that help determine a region's climate. For a deeper dive into climate mechanics, check out these helpful resources below.